Good afternoon. Today we're going to be talking about the algebra functions. Basically today just adding, subtracting, multiplying, and dividing functions. So I've given you several different examples here, and I'm going to hit these relatively quickly. They won't be the neatest things in the world, but we'll try to keep them organized to where you could follow. Probably the biggest thing you're going to be concerned with today is looking at notation. So in this situation, we are trying to find this first one, f plus g of x, okay? And essentially what that means is that we are going to find f of x plus g of x, and we are literally going to just add those two functions together. So when we have f plus g of x, we can rewrite that as f of x plus g of x. So I'm going to zoom in on this just a hair. I'm going to take f of x, which is x squared minus 4. And to that, I'm going to add g of x, which is x squared minus 6x plus 5. Okay, to add those together, since the parentheses don't have anything outside that'll affect them like a negative or multiplication or anything, I can simply combine these by combining like terms, and I'll get 2x squared minus 6x, and then adding my constants together, I get a plus 1. And that is my answer, ladies and gentlemen. I am complete. Okay, my next one, f plus g of 2, I have two options. Instead of, I could do f plus g of x, which I did, and then fill in 2, or I can find f of 2. Let's change colors here. So let's do a little bit of erasing. We'll say we can change that to f of 2 plus g of 2. So, two options. You can fill in 2 right up here and simplify, or you can work with each one individually. So f of 2 is 2 squared minus 4, and I'm adding to that g of 2, which is 2 squared minus 6 times 2 plus 5. Okay, if I simplify that, that'd be a 0, that would be a negative 3, and if I add those, I will get negative 3 as my final result. Okay? I could have just as easily gone, since that was f plus g of 2, I could have gone to f plus g of x, which is right here, and I could fill in a 2, and I would also get negative 3 as my result. Okay? The next problem, very similar, but we're subtracting, and the main thing you need to watch is we are subtracting g, so watch your order, minus f. And remember, when you're subtracting, you have to watch your signs. So subtracting is the same thing as adding the opposite of each one, and then it becomes just our last problem. So x squared and a negative x squared is 0, so they're going to sum to 0. We'd have a negative 6x, and then 5 plus 4 is 9. Okay, so this next problem, we have g minus f of negative 1. So what that's saying is, it's like g minus f of x, but the negative 1 goes in for x. So I could go right up here, and I could fill in negative 1. And I'll get 15. Or I could go into g of x and f of x and fill in negative 1 individually and subtract, and I'll also get 15. So either one of those is going to work for us. Okay. The next type, fg. I'm thinking f times g. So that can also be written as f times g of x. Notice this is not multiplication. That is like f of x. That's just the notation. I'm going to take f of x, which is x squared minus 4. I'm going to multiply that by g of x, which is x squared minus 6x plus 5. And I'm going to do a little distributing, and I'll have x to the 4th minus 6x cubed minus 20 plus 5x squared, sorry, skipping ahead there, minus 4x squared. Now I'm distributing the negative 4 through, plus 24x minus 20. So what did I do? Basically, I distributed the x squared through each one, distributed the negative 4 through each one. Okay, combine like terms, and I will have an x to the fourth minus 6x cubed plus 1x squared, or just x squared, plus 24x minus 20. Okay, so the f times g of x. So this next one they ask for f times g of 3. That's saying x is replaced with 3. So f g of 3 is simply 3 to the fourth minus 6x cubed. Whoops, let's undo that. We're replacing, remember? Let's try that again. Minus 6 times 3 cubed plus 3 squared plus 24 times 3 minus 20. If we simplify, we will simply get negative 20. The next grouping is g divided by f. So that's g of x divided by f of x. These are actually the simplest in the sense that there's usually not much you could do with them. G of x divided by f of x. Now, the only way you could simplify this, you cannot cancel out the x squareds. The only way you could simplify this would be to be able to factor it and get a common factor to cancel. So if I actually factor, I'd have x minus 5 and x minus 1. And in the denominator, I'd have x minus 2 and x plus 2. Since I don't have a factor common, like there's not an x minus 2 on the top and bottom or an x minus 1 on the top and bottom, I'm not able to simplify. So technically that is your best answer. Now, when you divide, that does lead me to a domain issue. Everything before this was a polynomial, which means its domain was all real numbers because you can fill anything you want in for x and get a y value back out. This one, on the other hand, has restrictions, specifically where the denominator is 0. So remember, that can't be 0. So therefore, I can say x minus 2 can't be 0. Since I've already factored it, that tells me x can't be 2. And x plus 2 can't be 0, so x can't be negative 2. So basically, we're talking negative infinity up to negative 2, union negative 2 to 2, and then 2 to infinity. I'm just going to leave it in this form right here. So that would be my domain, all real numbers except positive and negative 2. Okay, finally, to wrap this section up, g divided by f of 1 is g of 1 divided by f of 1. Or I can take my actual function, this one, and I can fill in 1 in the numerator and denominator. Okay? Doesn't make any difference. It all works out the same way. So if I simplify 1 squared minus 6 times 1 plus 5 divided by 1 squared minus 4, that would be 1 minus 6 plus 5 over 1 minus 4. So that'd be 6 minus 6, or 0 on the top, over negative 3. 0 split up into 3 parts would be 0. So g of f of 1 is 0. And that's it.